Hello and welcome to week 10, lecture 50. So in last week we were discussing about recent advances in turbofan engines, and I'm sure you must have enjoyed that part and you must be having the curiosity what all are the new developments which are going on for say new turbofan engines, and you must have referred some good research papers which will give you the exploration of what all need to be understand in terms of say aero engine gas turbine cycles. This is a really very interesting domain to work with, and if you go ahead with, you will realize the upcoming engines like variable cycle engine, hybrid engines, turbofan engine with intercooler and regenerator, they are the future for turbofan engines. And those who are doing their graduation, they can explore the possibility of doing their projects or maybe their assignments, small problems they can solve to build the confidence. And if you recall, we have also solved a numerical, that's what is a special of its kind for intercooler and regenerator. Now in this week we will be discussing about the new kind of engine, new in the sense like what all we know, and now we are adding with the kind of engine that's called turboprop engine. We will be discussing about the advantages and challenges of turboprop engines. We will be doing the thermal cycle analysis for the single spool and two spool turboprop engine, and we will try to compare turbojet engine, turbofan engine and turboprop engine along with the tutorials. So that's what will be giving a new kind of flavor. Let me tell you what all literature you are referring, what books you are referring, or what courses you have done at your UG level, or what course you have done at your PG level, or you are doing at your PG level or PhD level. Most of the time the discussion about these engines are not included because of short of time or maybe because of lack of literature. So let's try to understand this in detail within this week, and let's start with. So here in this case we have our understanding about the turbojet engine. So initially we have started discussing about the single spool turbojet engine, and we realize the thrust, that's what is our major requirement for the aircraft engine. And for this engine, the thrust, that's what will be generated by all these components, and mainly the exhaust velocity which is coming out from the nozzle, that's what is responsible for the generation of the thrust. Later on we have realized with the demand of higher thrust, with the requirement special kind of application, people they moved with say two spool turbojet engine configuration. Even with that they were not satisfied. The new consideration that has come in terms of fuel economy, and for that purpose like thrust can be addressed by two ways. One, it is by addressing the mass flow rate, and second, that's what is by addressing the exit velocity from the jet or from the nozzle. And we have discussed about say low spool turbofan engine. We have discussed about the new kind of configuration where we have high mass flow rate and our exhaust velocity, that's what will be lower, and that we have defined as a high bypass ratio engine. So we have this kind of engines, they are already been existing with. Now the question will arise, what and why we need of this turbofan engines. So let's try to recall this kind of configurations here. So this is what we know in terms of our turbojet engine. What is happening, let's try to recall. We are having our intake, that's what will be decelerating the flow, and as per the requirement at the compressor phase it will supply the flow at Mach 0.2 to 0.5. Then we will be having compression, that's what is happening inside the compressor. This compressed air with high temperature and high pressure, that's what will be injected inside the combustion chamber. Well, we will be adding the fuel and burning of the fuel that will be happening. That's what is generating the flue gas, and this flue gas, that's what will be striking on the turbine blade. The rotation of this turbine blade, that's what will be rotating our compressor blades. The gas which will be coming out with high temperature, that's what we will be taking the benefit in terms of conversion of this high enthalpy into exit velocity. That's what we are doing by means of this nozzle, and we are having the exhaust thrust. So this is what is known to us in terms of say turbojet engine. Let's think of this engine. Suppose say I want to use the enthalpy which is coming out from the turbine for some other purpose. I don't want to generate the thrust. So question will come, what we mean by that. So here if we look at, this is also a kind of turbo, say it's a turbojet engine, but we say this as a gas turbine engine. So this is a different kind of variant. In construction, if we look at, we are having extended shaft here, and my exhaust is not with the nozzle. This is my constant area exit, that's what is. Now the thing is here, what shaft we are having, that shaft we can say it is generating the shaft power. So the amount of energy which was coming out from the turbine, now we will be adding additional turbine stage which will generate the shaft power, rather generating the jet, means the exit. Now this shaft power, that's what we can use for different purposes. One of the purpose, it is for rotation of the generator. We can say it is for the power generation. So all our land based power plants, they are working on this principle. So this shaft, that's what will be connected with the generator which will generate the electricity. Secondly, I can use this shaft for my special purpose. I will be connecting this shaft with the propeller, and I say that as a turboprop engine. So that's what is our this week's discussion. I can even connect this with the rotor which we are using for our turbo shaft engine, which is mainly being used for helicopter engines. So that will be the discussion for our next week. So let's try to understand what we mean by this propeller. So here if we look at, this is representing one of the propeller blade. If we look at carefully, say here we are having the base, or we can say base shank, and it is having say the blade which is having different kind of aerofoil. From this region I say hub, and this region I'll say tip. So it is having different kinds of aerofoils. So aerofoil, we know it is having a special purpose. These aerofoils which are generating basically a lift, and if you recall when I was discussing in second week, these aerofoils, they are having special purpose. Suppose say if I am using that for the compressor, the purpose is to compress our working fluid. If I am using this lift force by rotation in such a way that I can utilize the lift force in order to accelerate my flow, and that's what we say in terms of turbine. So in line to that, this is what we say is a propeller. So here if you look at, this is representing one of the cut section where we are having propeller blades. 6 blades, they are connected here with the hub. Now the question is what we mean by propeller, or what is the need of propeller. So if we look at in conventional language, the main function of this propeller, it is to displace the air and pull it behind itself. Means suppose if I consider here my air that will be sucked inside and it will be forcing that to go out, I say that as an action. And what is happening, the air movement what we are having, that's what is generating the differential pressure, and this differential pressure, that's what is responsible for the push of this air, what we can say is generating my thrust. So it is nothing but opposite reaction what we have. So meaning is, if by some mean, if you are able to say movement of air in more quantity, and if we pull it behind the propeller, then we can generate more amount of thrust or the forward propulsion by using this mean. That's what is the whole purpose of providing the propellers. So if you recall, you must have studied this in your basic of physics. This is nothing but this is working on a principle of third law of Newton. It says for every action there is equal and opposite reaction. So now you must be realizing the thrust we want to generate by using this propeller. So till now for turbojet engine, what we realize, the thrust we were generating by the exhaust from the exhaust gas and the nozzle. In the case of turbofan engine, we have discussed around 70% of the thrust, that's what will be generated only by the fan, and that's what we say high bypass ratio engine. Similarly for the turbofan engine, so here we are having this as a propeller which we will be using for the generation of the thrust. So the concept of using this propeller, it's not new. Say very first engine which was developed by Wright brothers, for them they have used inline engine, that's what is a multi-cylinder engine, and that multi-cylinder engine, it was used to rotate these propellers. Later on, people they have explored different kind of possibility. Here if you look at, this is what is Pratt and Whitney radial engine, it's a 2800 engine, that's having say 18 cylinders, they are arranged in a radial fashion. So these all are connected with say crank and piston mechanism, and here it is connected with the connecting rod. That connecting rod, it is connected with the shaft, and this shaft is connected or on which we are fixing our propeller. So basically by this engine, what power we were generating, that's what is being used to rotate the propeller. Similarly, these are other cut sections. So here if you look at, this is famous Merlin engine. Here in this case it is with the duplex cyclone engine. So you must realize here these engines were also existing and they are also in use as on today. Also we are using this kind of engines. There are many propeller aircraft which are run by using this say multi-cylinder engines or multi-cylinder internal combustion engine. Now if you look at carefully, you must be realizing as my requirement of the power is increasing, why I am looking for more power? Because I want to generate more amount of thrust. For that purpose, the size of my engine, that's what will be increasing. At the same time, the weight of the engine will be increasing. Similarly, if we are talking about this engine, they require special kind of cooling, means additional cooling media also is required, and that's what will lead to increase the overall weight of the engine. And for all 9 weeks, what all we are discussing, we are in favor of gas turbine engine because it is having higher thrust to weight ratio. That's what is a preference for using this as for say propulsion purpose. So let's try to look at how exactly these turboprop engines are looking like. So here if you look at the construction detail for this turboprop engine is in line to what all we are looking for turbojet engine. The additional component here you will see is the gearbox, and this gearbox, that's what is connected with the propeller. So this we say is a single spool turboprop engine. So in order to rotate this propeller, the power will be supplied by this single or say single spool turbine stage. If we are using this kind of configuration in which both propellers and compressor they are being run by say this turbine, basically it is known as a gas generator. So conventionally people they are defining this kind of configuration in which the turbines they are defined as a gas generator. Just look at on the other side, on the right hand side, if you look at, there also we are having the similar kind of construction, but you can easily differentiate the construction here. Say if we look at, say here in this case, the compressor, that's what will be rotated by this turbine. So we are having two spool configuration, and the propeller, that's what is connected with the turbine, additional turbine stages, that's what is used to rotate our propeller. And this kind of configuration, it is called power turbine or the free turbine. So this is our two spool configuration. So now I'm sure you are familiar or you are getting idea what we mean by single spool turboprop engine and two spool turboprop engine. Now here if you look at, the question may arise in your mind, sir, what is the purpose of gearbox? In both the cases, if you look at carefully, we are having the gearbox. So any guess for that? If you recall, we were discussing about the turbofan engine where we were discussing we want our fan to be rotated at lower speed. The difference you can easily guess here. Be careful, this turboprop engine and turbofan engine, they are different. What is the difference? Here this rotor that is not within our casing, it is freely rotating in open air. That is the reason why it is called propeller. When it is enclosed inside the casing, it is called fan. So do not get confused with these two configurations. I will show you different types of propeller, you will realize the thing. Okay. Now here in this case, if suppose if I consider this propeller is rotated at the high speed, what will happen? Say this propeller is connected near the hub, okay, and this is acting like a cantilever beam. Now because of the centrifugal force, there may be chances that it will be having very high stress that will be focused near the hub, and during rotation it may come out. It is very dangerous. It will give a catastrophic failure. Okay. Similarly, these dimensions what we are looking for, they are in terms of meters, maybe 1 meter, 2 meter of dimension we are having. That means when I am moving towards the tip region, you are aware of my tip Mach number, that is what will be going to be increased. If my tip Mach number is increasing, my flow will go supersonic in that region. If my flow is going supersonic, that means it will be disturbing my aerodynamics, and that is what will lead to reduce the efficiency of this engine. Okay. So what is the meaning of that? I should not rotate this propeller at the high speed. Suppose if I consider this is the configuration, in order to generate sufficient amount of power, your compressor must rotate at the high speed. And since it is on the common shaft, so it will be rotating at high speed. That is the reason why we are looking for this gearbox. Similarly, here in this case also, say we are looking for the rotation of this propeller to be very low, maybe in terms of 1200 to maybe say 3000 rpm, not more than that. Maybe 3000 also is a big number. So under that configuration, we are looking for this gearbox. Okay. And what is the purpose of gearbox? That is what you must have realized. When I say gearbox, you again we recall say your turbo fan engine with gearbox, or say gear turbofan engine. Yes, it is similar to that only. Okay. So let us try to understand the construction of this turboprop engine. So here if you look at carefully, say this is representing the fixed shaft turboprop engine. So somewhere here we will be having the intake. The air will be sucked from this intake and it is supplied to centrifugal compressor, where it is subjected to high pressure rise. This high pressure air, then it will be entering inside the second centrifugal compressor. The exit of this second centrifugal compressor, that is what will be going to annular combustor, or say reverse annular combustor. Just look at the construction of this combustor. It is different from what all we have looked at for our configuration. If you recall, when I was discussing, when we are using the centrifugal compressor on say rear side or maybe for HP, we will be having this kind of configuration. And here if you look at, these are the turbines, and from there we will be having the exhaust. Now these turbines, they are rotating this compressor as well as it is connected with the propeller. Okay. So that is the reason it is called fixed shaft turboprop engine. So do not get confused in sense of understanding here. Just look at here. If we look at, this is just a reverse of what all we were discussing. I will be having my intake somewhere placed here, from where it will pass to say axial compressor stages. That is what will be followed by say centrifugal compressor, and this is we are having say reversible annular combustor. The gas that will be expanded inside these turbines, and this is my exhaust. But carefully observe here in this case, these two turbines, they are not connected, they are separate one, and that's the reason why it is called split shaft or free turbine kind of configuration. This free turbine, that's what is connected with the gearbox, and that is connected with our say propeller. So this is the kind of configuration we are having. So here if you look at, this is representing the intake, and here we are having the exhaust nozzle. Similarly, here also you can clearly see the intake and the exit. So like for the line diagram we are showing in a reverse way, but do not get confused. So here the question will arise, why not axial flow compressor? Why we are having centrifugal compressor? You must be realizing the whole purpose here, it is for the power generation. Okay, and here if you look at the compactness, that's what is of major requirement. Lightweight also is a major requirement. As we go ahead, you will realize what all are the importance, why we are having this axial centrifugal compressor combinations. Okay, here if you look at this, all are the aircrafts which are connected with the different engines. So here this Pilatus and Saras, they are using PT6 engine. They are the turboprop engine, one of the most efficient engines developed by Pratt & Whitney, which is generating power of say 895 kilowatt. Here in this case, if we look at, this is the propeller. I will discuss after few minutes. This propeller, it is connected in the front side, and here we are having exit. So this aircraft, it is looking for single engine. For Saras, I'm sure you must be aware of, this is the development by say Indian government, say NAL Bangalore. It is involved greatly in the development activity for the Saras. This project was started in 80s. Later on it was stopped. Initial target was say 14-seater aircraft. Now the new version, that's research is going on, the development activities are going on, and we are about to reach to final stage by 2025, where the whole requirement is 19-seater engine. So that's what is connected with the turboprop engine. This turboprop engine, it is procured from say Pratt & Whitney. So here if you look at, I'm having different kind of configuration, where if you look at my propellers, they are connected on the rear side, and here I am having intake. Let's look at here. This is what is Antino AN22. You must be aware of, this is what is largest or the biggest aircraft that is rotated by using propeller engine. Here if you look at, we are having say combination of 4 propeller engines. Okay, similarly this is what is with say Airbus A400, mainly for the military purpose, which is having say 4 propeller engines. Similarly, this is Lockheed A30 Hercules, which is also having turboprop engine, and that is fitted with Ellison T56. And here in this case, this is what is with say TP400 D6 engine. Now if you look at carefully, these turboprop engines, they are having a special application that varying from say business jets towards say your regional transport aircraft, towards say transport aircraft, and that is also having say military applications. Now here in this case, if we look at carefully, say the propeller, that's what has been placed in the front. Okay, similarly here if you look at these propellers, they are connected in the front side. Here if you look at, these propellers are connected or they are placed on the rear side. Now just try to understand, when we are connecting our propeller or we are placing our propeller before intake, then this configuration is called puller kind of configuration. The whole purpose of this propeller is to pull the air. So it is giving the pulling action. Okay, there are many advantages and limitations of puller kind of configuration. Most of the engines, what all you are looking at in terms of say transport purpose, say small aircraft, they are having this kind of configuration. There are many engines in which if you look at the propeller, it is been placed on the rear side, and we are having our intake that will be followed by the compressor, and we will be having turbine on the later stage which is connected with this propeller. Here also for Saras, if you look at, say we will be having our propeller, this is what has been placed on the rear side, and here somewhere we are having our exhaust nozzle. So just realize what we mean by puller kind of configuration and pusher kind of configuration. This is basically pushing and pulling of the air. That action, that's what is being used for the generation of the thrust. It is designer's choice. It is decided by the aircraft manufacturers, and later on, according to the requirement by the aircraft manufacturers, engine designers, they will be designing their engines. Okay. Now, the application, what all we were discussing, it is not limited there. These days, people, they are having special attention of this turboprop engines. Say this is representing Turkish Akinvi UCAV. So this is connected with the turboprop engine which was developed by the Ukraine, and this is for the military purpose where you can accommodate your missiles, you can accommodate your bombs. This is one of the famous UAV these days. Similarly, this is with say European MEL, and that is connected with GE Catalyst engine. Similarly, here if we look at, this is representing say General Atomics, and that's what is having say turboprop engine developed by Garrett. Here in this case we are having say Boeing UAV. Similarly, this is with the Tapas, and the engine which was fitted with it is Saturn. So this is a special application. Now the question will arise, why all of a sudden people they are moving towards say prop engines, and that too it is for the UAV. If you recall, when I was started discussing about this course, in very first week also I was emphasizing the future of gas turbine engines, and these engines they are having great applications these days, and that's the reason I feel we need to have more emphasis on these turboprop engines. So question will come, what is the reason why are we moving towards a turboprop engine, and that too it is used for UAVs? So the reason is very first, efficiency at the lower speed. So these turboprop engines we have discussed, they are running at low speed, and that's the reason they are very efficient, and that can be used for different missions which are related with the loitering, surveillance, and say slow flight operations. Because of fuel economy, they are giving the longer endurance and extended range. Similarly, the payload capacity is higher. So if we are looking for say special kind of application where we want to accommodate cameras, sensors, communication equipments, even we have seen maybe bombs and missiles also can be accommodated, and that's the reason why this engine is coming into the picture. The biggest advantage of this kind of turboprop engines or turboprop engines we have discussed earlier. Say my thrust, that's what is inversely proportional to my exhaust velocity. So the beauty of these turboprop engines, the exhaust velocity is lower. That means we will be having our thrust to be very high, and that's what is giving short takeoff and landing capability. Even it can run on say unprepared surface. That's what is giving the flexibility and versatility for the UAV application. Now flexibility in the missile profile, that's what we have discussed. It is having number of application. Even for say our UAV purpose, it can be used for surveillance, reconnaissance, cargo delivery, scientific research, and there are many more applications what we have. Here when it is rotating at lower speed and altitude, that's what is generating low noise, and this low noise it is very important when we are having say secret operation or maybe surveillance missions. There it will give the big benefit. These engines are more reliable and durable, and long duration and application in remote and harsh environment, that's what has given the priority to these engines. They are more cost effectiveness both in terms of operation as well as maintenance purpose, and this can be customized as per the requirement, because basically these engines are compact and versatile, and there are different applications what all we have discussed with, and that's the reason why this UAVs these days people they are preferred with using this turboprop engines. Even turbojet engines also can be used, but the priority it is with the special requirement, and this special requirement that can be fulfilled by using these turboprop engines only. Now let's discuss about what all are the advantages of turboprop engine, and that's the reason why it is been applied for aircraft also. So what all are the benefit? It says it is generating very high takeoff thrust, and that's the reason why my short takeoff length is required. So most of the regional transport aircrafts what all you are looking at, they are with the turboprop engines. So Government of India has launched a scheme, it is called UDAN. This UDAN scheme which is connecting small cities with the big cities. And the thing is, all small cities now they are having airports. Maybe it is not possible to make big airports because of many constraints, but with the small airports and small runway, these turboprop engines they are working absolutely fine. They are much more efficient. That's the reason why they are economical for the passengers, and that's the reason why the next market, next requirement by these airline companies will be with the turboprop engines. Same way we have seen like these engines are more efficient because the amount of air that's what is going in, amount of fuel requirement that's what is lower. So for particular thrust requirement my fuel consumption is lower. When you are comparing with turbojet engine it is very less. This frontal area what all we are looking for, it is lower for this turboprop engine compared to our IC engine driven engines. Just remember, turbo term what we are including, that means it is something related with the rotating component, and turbo it is a specific word. It is not that propeller engines and turboprop engines are same. These propellers as we discussed that can be run both by IC engine as well as with gas turbine engine. These turboprop engines can be operate more economically with small speed range, and it says they are more economical for the speed in between 200 to say 800 kilometers per hour. These engines are easy to maintain and they are having lower noise and vibration. That's what is an attraction for. Now, multi-shaft arrangements, what all we have look at in terms of construction, that's what is giving the flexibility. Oh, कहाँ से निकाल? गिर गया लग रहा है. या फिर यहाँ यही फिर ले ले फर्स्ट से, या ये साइड है, इसी साइड को फर्स्ट से यहाँ से निकल जा रहा है. ओके, ब्लॉक लूज हो गया है. हाँ सर. As we have discussed, we are having multi-shaft arrangement that's possible with this turboprop engine, and that's the reason it is giving more flexibility in terms of operation over the wide range as per our requirement of the speed. These turboprop engines can be adopted for the variety of aircraft size. As we have discussed, it is in terms of say ranging from small commuter plane to say larger aircraft, and that can be used for different kinds of mission, what all we were discussing about. Turboprop engines, they find their application in vertical takeoff and landing also. Here if you look at, this is not the helicopter engine, just look at, this is the aircraft. It is Osprey V-22, which is having VTOL capability. That's what is giving the possibility of vertical takeoff and landing. So in overall, if we look at this turboprop engines, they are having wide range of applications. They are much more efficient compared to what all we were discussing in terms of turbojet engine as well as turbofan engine. The only possibility here, or what all we say in terms of what all are the challenges for this engine, that will give the more clarity. So let's discuss about what all are the challenges with these engines. So the main challenge, it is with the propeller efficiency, because when my speed is increasing, that's what will give the shock formation and flow separation, and that's what will lead to give the limitation in terms of say maximum speed. So if you recall, we were discussing about say efficiency of all the engines. There we have discussed for turboprop engine, they are much more efficient for the low speed kind of configuration. So mainly they are having say subsonic flight limited to say 400 miles per hour and altitude is say 30,000 feet. The propeller is connected with say gearbox, reduction gearbox. Sometimes in order to have the great control of the flow, these propellers, they are made up with the pitch control. So during operation, they can change the orientation of this propeller, and that's the reason why it is subjected to very high weight. Okay, and it says like this weight of the engine, that's what will be 1.5 times compared to our conventional turbojet engine for the same say gas generator size. It required say reduction gearbox, that's what will lead to increase the cost, and it is consuming a lot of energy. That's what is also required more space in order to accommodate this gearbox. So larger size gearbox, when it is connected upstream, then we can say our intake or intake design, that's what will be more challenging. So if we look at, if we recall, we have seen the cut section of these engines where we can clearly see the intakes for these engines, they are different compared to what all we have observed for turbojet and turbofan engines. No doubt here my air flow rate requirement, it is less. Then if we look at, since we are having the gearbox, it may be single or double planary version where we are having say rotating components, and there are chances that it will subject it to foul, and if it will be coming out, then it will damage both to the engine as well as to our aircraft, and that's what is putting a lot of challenges in terms of application of turboprop engines. So today, if we overall discuss what all we have started with, is to understand what we mean by turboprop engine, what is the function of the propeller, and why we are putting say major attraction towards the use of this turboprop engine. There are many advantages, there are challenges also, but these turboprop engines, they are the main role player for the future aircrafts as well as for the UAV purpose. So here we are stopping with this session. In next week, we will be discussing about say how do we proceed with the cycle analysis for both single spool configuration as well as two spool configuration. So thank you very much.